Good morning, or almost afternoon, I guess I should say. How is everyone doing today?
I don't know. It's almost lunchtime and I'm still a little sleepy.
Uh-oh, that's not good. Okay, so I let you guys in really fast. I didn't do great on attendance today, so I'll figure it out in just a second. I do have a warm up for you guys. Okay, now get out of the way. The little bar is in the way there. Annoying. All right. Try those three while I'm figuring out who's here. Do those without a traditional algorithm. So Essay's here, Tristan's here, Evelyn, Karina, McKenna, Alyssa.
Hey, I'll be right back. I'm gonna go grab a whiteboard, okay?
Okay, I think I have everyone here except for Bethel. Is Bethel here? Did I dream that she's not here? Oh, here she is. All right, so how are you guys doing with these non-traditional ways? You're doing okay? Hopefully you wrote those 3 problems down. Somebody want to describe to me how you did any of them?
I can go first. I don't know if you can hear me.
Yeah, go ahead. I'm ready.
The first one I did 40. Well, I added 3 to 47, which made it 50, and then I subtracted 3 from 26, which made it 23. So it ended up being 50 plus 23, which gave me 73.
So you did plus 3 for the 47 and you did minus 3 for the 26.
Yes.
Is that true? And so you got 44 plus 23.
50.
Oh, 50. Gosh. 47 plus 3 would be 50, wouldn't
I
it?
was doubting myself.
No, you're good. 50 plus 23. So you got 73. Nice. And so what is that method called? Does anyone know?
Kind of. What's the name of it?
Is it the compensation model?
It is compensation. Think about it. You're compensating, right? You're adding 3, subtracting 3. That evens each other out. So excellent. Did anyone do something differently for number 1?
I did. I kind of did almost the same idea, but I wrote it down right here. I don't know if you can see. So I did, I just wrote down the problem first, 47 plus 26. And then I broke it down. I just added 40 plus 20, and that equals 60. And then I did 7 plus 6 equals 13. And then I added 60 plus 13, which equals 73.
Nice. Excellent. Hold that up one more time, Evelyn, so we can see it again. Okay, so what strategy was Evelyn using, if you had to name it?
Isn't that partial products?
Not partial products, because that would be multiplication. So be careful. I think you're on the right track when you're saying, you know, you're thinking of breaking it up. You could call it partial sums. Yeah, just not partial products. Or you could call it decompose by place value, right? She didn't totally decompose by place value, but she decomposed the 26 by place value, right, into 20 and 6, and then added the 20 to the 47. So, and what allows us to do that is the associative and the commutative properties, right, of addition. Excellent. My slides are on Canvas. They're also in OneNote. So they're in the week overview, or actually the week presentation. They're about midway down the page. All right. How about the 53 minus 27? Who wants to share a strategy they did for that?
I could go.
Okay, Bethel, I'm ready.
So I don't know if y'all can see it. I did on paper, but I did the number line one. So I started with 53.
Just hold it really close and
Can you see right there?
so we can look at it. Yeah, perfect.
So I started with 53, and then I know that 53, 5 minus 2 equals 3. So I did, I went back by 20s, which is 33. And then I just subtracted 3 to make the 33 a 30. And then I subtracted 3 more to make 27. And then I added the jumps that I made. So 23 and 3, which equals 26.
Nice. And you could have done minus 20, minus 3, and then minus 4, right, on your number line. So you were actually subtracting them and you end up there. So just don't be freaked out if yours looks different than Bethel's. Bethel's is correct, but there's lots of strategies, right? Good job. And so you use the number line. Excellent. And you really were decomposing those just by friendly numbers, probably. So there you go. Excellent. Anything else on the subtraction?
Oh, sorry. Go ahead.
I did the break apart. I don't know if you can see number 2.
Nice. Yeah. So you did 53 and then you did minus 23 to get you to 30, and then you did 30 minus 4 to get 26. Excellent. Good. Anyone else? Somebody else was going to talk.
Oh, me. I had a different method. So I had kind of a question. Is the count up method where you start at 27 and then count up to 53?
Yes.
Is that the So I
Yes.
kind of did that method. Oh, it's so tiny. I don't know if you're going to be able to see that. But so I started at 27 and then I bounced and then I went up tens until I hit 47 and then realized that I can just go straight to 53 from there. So then I added 10 plus 10 plus 6, which equals 26.
Excellent. Yep. You guys are doing great. So if the more you practice them, the better you'll get at them, right? So you just have to keep practicing them. How about the last one? How about for multiplication, 16 times 28? What did anyone do on that one?
I did the partial products method. Sorry, was someone else going? So I did the partial products method, and first you do 8 times 6, which is 48 because you're in the ones place. And then I did 8 times 10, which is 80. And then you move on to the tens place, and that's 20 times 6, which is 120. And then 20 times 10, which is 200. And then you would add all those values together and get 448.
Nice. I don't know why I'm writing in this purple over there. You can't really see it, but hopefully you can see it well enough. Good. Now, did you do it like I did it this way? Or did you do it in a box, like a rectangular one?
I kind of just did it like you did.
Nice. So the one thing I want to tell you about this is I don't think she says it in the video, but I usually say it. You guys were taught the traditional algorithm, which is 16 times 28, where you did something like, okay, 6 times 8, and you said it was 48. So you wrote an 8 down here and you wrote the 4 up there. Do you remember that? And then you did 8 times 1 and 8, and then you got plus 4. And so you wrote 128. So do you see that 128 comes from both of these put together? And the idea there is you were taught a shortcut first instead of being taught the long way home. So this is the long way home. If somebody would have taught you the long way, you could understand the shortcut better, right? So you have to make sure you show them where it comes from. That's why you see the area model a lot, because then they see where these things are coming from. The other thing that our traditional algorithm ignores is it ignores place value, because when we do it traditionally, we go, oh, 8 times 1, but you just spent a lot of years teaching them that that 1 is not a 1 because it's in the tens digit. So it's really a 10. So that's why this strategy is very nice and helpful to help students preserve place value and understanding. So good job. Anyone do anything differently on that multiplication?
I would just like to comment on that because I have noticed with my students that when I did try to do just the original method I was taught, it was way harder for some of them got it, but some of them didn't. So I had to figure out by myself. I was like, oh shoot, how do I break this down to where it's going to be even smaller? So it is true that does work way better, and I have experienced it.
Good. Yeah. And we just didn't realize how much we were taught that, right? It was just drilled into our heads, but a lot of people got left behind then in math. That's when the math started falling apart for them. So good. Thanks, Evelyn, for saying in practical you've seen it. So, and now when you have access to my slides, Vanessa, did you find them, I hope?
Yes, I did.
Okay,
I just
good.
I had them pulled up for the subtraction and addition, and then I was like, where did the other ones go? But I found them. Thank
Okay,
you.
good, good. So, and I do just want to take a minute on Mindfulness Monday. This is really literally a minute. What's nice is you're going to write down as many things as you can that you're grateful for 1 minute. And then if you keep this piece of paper somewhere that you can refer to when you're stressed, sad, right, bored because it's COVID or sick or whatever it is. So keep this list. So I'll start the timer now. Go ahead, 1 minute. All right, so that was your quick minute. Did you guys write down a lot of things? Yeah, the more I sit there, the more I think of. That's why it's kind of a fun activity. And sometimes, like, if you're really having a bad day, instead of just saying, I'm grateful for family, that's when you start listing each person out because you're like, okay, I need to be grateful for more of this. I'm grateful for my mom. I'm grateful for my dad. I'm grateful for my dog, right? I'm grateful for all these things. So, this is a nice, fun way to remember what we're grateful for, but just keep practicing, right? Our mindfulness Mondays. All right. Here's a multiplication problem. See if you can write down what the multiplication problem is that was done. Just take about 10 seconds. Think about it. All right. Anyone tell me the multiplication problem we're doing in this picture?
12 times 8.
Yeah, it's 12 times 8 or 8 times 12, right? Since we have the what property allows us to switch that?
The commutative.
There you go, the commutative property. And where is our answer? Where is our product?
You add the products of 10 times 8, which is 80, and 8 times 2 is 16, so it would be 96.
Very nice. So my answer is 96. Now, you might be able to write down mathematically what you did. And hopefully it looks something like this. 8 times 10 plus 2, which is 8 times 10, just like Hannah just said, and 8 times 2. And then we sum those. So that was the distributive property over, right? The distributive property of multiplication over addition. So nice job. Now, what's interesting is we can use the same picture for division. Yeah, do you remember your exit ticket you did the other day where I gave you the products and then you had to figure out what those were? So students can break down mathematics this same way, division, because there's a huge connection between multiplication and division, right? So that's what we're going to focus on today because division strategies are really important. So let me find my document for you. I'm going to have you work in your groups on the next few slides. Now, you need to have access to the slides, but some of you, if you're finding the slides annoying or the Jamboard's annoying, something like this, this is just a document. And if you have access to a printer, you could print it out. I wouldn't. I would just use it on the screen and help me use it to answer the questions. I just wouldn't print it out because I don't like printing things anymore. You can access it electronically. There it is as a document, or you can just look at it on my slides. So what I want you to do is I'm going to put you in your breakout rooms, go through problems 1 through 3, and you can make your own whiteboard, use the document, whatever you want, but be prepared to discuss these things together. Okay. So you can understand what's happening and be sure you're ready to answer other groups. Now, if I leave you in there too long and you want to keep going, you can keep going on problem 4, 5, 6, and 7. Just read through the slides. Okay. So what you're going to be doing is you're going to look at this and you're going to say, okay, what multiplication problem was Lola trying to do? Was she doing a division problem? Right? What's happening there? What was Lola, sorry. What was Lola's strategy? Right? And they use multiplication and division. So Lola was actually doing 32 divided by 4 using some multiplication facts she knew. And then it asks you to do Lola's method on some other problems. So that's what I want you to do. Questions? Okay, I'm going to put you in your breakout rooms. Hopefully you all have your numbers there for me. I'm going to check it out. Sorry, you can get started on those even before you're in your breakout rooms because you have access to them.
I put the wrong number for my breakout room for some reason. So I'm 8, not 6.
Okay. Who else is 3 besides? Oh, no, I think I know who it is. Never mind. 4. I always forget Jessica in that room. Sorry, Jessica, I'll put you in there in a minute. You don't know how much faster this is when you guys put your numbers there. It helps me immensely. You're like, we do know because you take less time. Okay, and then just call me to your room if you have questions or need anything. And I'll leave you in there for, I don't even know what my thing said, how many minutes? 20 minutes, maybe not that long. We'll see. Maybe about 10. Okay, I hope you're all in the right rooms now. All right. So, if you had the worksheet, maybe it was a little bit easier for you to follow than the slides. I don't know what you think, but I was in one of the breakout rooms with, who was I with? Sydney and Michaela. And Sydney described this, what I'm showing on my screen right now, 56 divided by 8. Sydney, do you want to explain? This is what your picture looked like, right?
No, I did. Oh, wait. Yeah, I did. Sorry.
I was like, I thought I looked at your picture before I drew it. So you want to explain what you did?
So I just, wait, we're doing the first one, right?
Yeah, we're just doing 56 divided by 8. Do you see the problem right there?
Yeah. So I just did, well, we know it's 8, so I just broke 8 down and split it into 5 plus 3. And then, like, is that what you want me to talk about?
No, I thought you did your picture just like this.
Yeah, I did.
Where you said, okay, you want to get close to 56. So you knew 8 times 5 was 40.
Yeah.
Right?
Yes.
Okay. I'm like,
I thought you wanted me to talk about the first one. The one that you're showing.
Oh, over here.
Yes.
This one.
I was so confused.
Sorry. No. Sorry. Sydney,
Okay,
go ahead and do this one.
Okay, so I did 5 and 2. So I just did 8 times 5, which is 40. And then the next that's left over is 8 times 2, which is 16. And then I just added those, which is 56. And 5 plus 2 equals 7. So 8 times 7 equals 56.
Nice. Yeah, I kind of skipped over what Lola did. I keep calling her Yola. My sister-in-law's name is Yola. So that's why I keep calling her that. So what Sydney and Michaela were talking about was when we have 56 divided by 8, we can get close. Let's use facts we know. So a fact that a lot of kids know is 8 times 5. So if I do 8 times 5, I'm already at 40. Well, then I have 56 minus 40 left. So I have 16 left. So how many groups of 8 fit in 16? Well, 2 groups of 8 fit in 16. So this might look like a multiplication problem, but we're showing it as a division problem. This is what's called the missing factor model, right? So when we think of a division problem of 56 divided by 8 equals what? A lot of times we rearrange it in our brains to say 8 times what gives us 56, right? So that's what we're doing in our brains. And that's what Lola did here with her 32 divided by 4. She said, well, I need to get close to 32, but I know 4 times 5 is 20. So she was saying 4 times what gives me 32? And she said, well, she knows that 4 times 5 gives her 20. And then she's going to have 12 left. So 4 times 3 gives her that 12. So she's going to get the 32. So it looks like an area problem for multiplication, but we're using it as division, using the missing factor model. Does that make sense? Okay. Karina shook her head yes, so I feel good. Okay. Now, what about when you have a problem that doesn't work out perfectly? Can kids still do a multiplication, or sorry, a division problem where you don't get an exact answer? 63 divided by 12. Did anyone try this one and figure out how they split it up? And sometimes you're like, it's hard for me to pretend I don't know division, right? It's hard for me to put myself in my student shoes or just in general. Anyone try this one?
I tried it.
Okay, I'm ready. Share with me what you did.
Okay, so I don't know my 12 times tables at all, so I just started with ones I knew. I kind of stole that girl Lola's method. I did 12 times 2, which is 24. And then I did 12 times 4, which is 48. And then I added those together, and then I realized, okay, that's 72, so that's too much. So I did 12 times 5, which is 60. And then I realized, so there's 5 groups, but then there's a remainder of 3. So I didn't know how to do the area model afterwards because there was a remainder, so that's weird.
Yeah, no, but I love how you were thinking it through, and that's exactly what kids will do, right? Did anyone, and we'll talk about how we write our remainder in just a minute. Did anyone else try something different? So, you know, first Alyssa said, well, I did 12 times 2 and got 24. So then I did 12 times 4 and got 48, but then I was at 72, so that was too big. So I went down and said, okay, this was 6. What if I go down to 5? 12 times 5 is 60. And then I couldn't fit any more 12s in 3. So we know that 3 is kind of our leftovers. Did anyone show it differently in a picture?
Sarah did it. I was totally lost, but then Sarah, she did it that way, but she also added the 3 in the box, and then she did 3 divided by 12 was 1/4. So we end up with 5 1/4. I don't know if
That's awesome. Show me that picture. Who has that on a picture?
I can't show you, but maybe Sarah can. Sorry.
Okay, can you guys see Sarah's? Okay, so Sarah drew this just like this. I can just add to my picture right here. And I will say 3. Because I wanted 63, but I didn't know what to write here. So then Sarah said it was 1/4. Right? So it was 5 and 1/4, which is the same as 5 and 25 hundredths. Yeah? Good job, Sarah. Anyone else do it differently? Anyone else use different math facts? Tell me if you follow this picture. I don't know my 12s at all. So I did 12 times 3 and got 36. And then I was like, ooh, 12 times 2 and I get 24. Now I know I'm at 60 and I had this 3 here. Well, notice if I multiply 12 times 3, I get 36. 12 times 2, I get 24. Or if I do 24 divided by 12, I get 2. 36 divided by 12, I get 3. So 3 divided by 12 must be my remainder here. Yes. So it could also be 5 and 3/12. Do you see my logic? Do you see how I did? If I'm thinking about 36 divided by 12 gives me 3. 24 divided by 12 gives me 2. So 3 is left. If I divide that by 12, that must be my leftovers. Yes? Nice, Amanda. I saw it. I saw that light bulb moment. I love those in class. So we're connecting multiplication and division, right? Questions on that? So our pictures don't have to look the same. right? And that problem of I have 3 left over, that's a great thing to have. Do you ever realize that when you're doing things in class with young elementary school students, a lot of teachers just give them all the easy problems? You might have had this experience in college as well. And then you go home for homework and none of the problems work out nice. And you're like, wait a minute, they're tricking us. Give your students problems that don't work out nicely, right? So then they can see, what do I do with that 3? Where does it go? What does it mean? What does it mean, remainder? Right? Okay. So then on your next part, it said Kennedy used multiplication to determine 508 divided by 4. He started with a multiplication fact he knew, 4 times 100. Use an array and symbols to show one way Kennedy might have used multiplication to determine the quotient. Did you try that one yet? You might not have been there quite yet. How many of you tried that one already? Nice. Amanda did. I think Karina did. Anyone else? Okay, what brave soul wants to try it? It can be somebody who already tried it or somebody who wants to try it live with me right now. Because we know, what did it say that Kennedy started with?
4 times 100.
Yeah, 4 times 100. And so was that 400?
Yes.
What do you want to do next? We got to get all the way to 508.
I can do that.
Okay.
Next I did 4 times 2 is 8. So that way I was left with just 100 because I thought that was easier than dealing with 108. And then I know 4 times 25 is 100.
Do you think kids would know that? Oh my gosh, sorry, I'm writing backwards. Do you think kids would know that 4 times 25 is 100?
It depends on how you taught them money.
Thank you, Elena. That is absolutely correct. Kids who know money know that 4 quarters are $1. So 4 times 25 is 100. Money is a great connector. So what's our answer to this? 508 divided by 4. What's our answer?
127.
Very nice. 127. Some of you are like, this is so backwards. I just can't even think this way. You can, you just have to practice. Now, what I want you to really practice is, how do I connect my multiplication and division together, right? So this was 508 divided by 4 is 27. And what we did mathematically, which we would know, we could write our math problem 4 times 127 equals 508. But what we did was we broke down this 4 times 127 into 4 times 100 plus 2 plus 25, right, equals 508. And so we did 4 times 100 plus 4 times 2 plus 4 times 25 equals 508. And some of you really like parentheses here. They are not necessary because of order of operations, which we'll talk about on Wednesday, but you might like them, right? They might make you feel better. They might make kids understand things a little bit more. So does that help? Questions, concerns? So you got to try these strategies or it'll be problematic. Okay. Oh, we could do other possibilities. This was just one possibility. Anything else you could do? Let's think of something else we could do for Kennedy. Instead, we did definitely still started with 4 times 100. Any other way we could break it down? We don't want to just reverse the order and make it 25 and 2. What if I don't know anything else? What else might I know?
You could break down the 25 more into 5 and 5 and then 4.
Okay, so what would I do next? So now, so far I'm at 400 and I want to get to 508.
So then you would do 4 times 5 and then 4 times 5 again. And then you, right? And then you would just do a 4 at the end.
Okay, so what am I at right now?
440.
I'm at 440. Where do I need to go?
Oh, you would actually have to add more.
I'm fine with it. Evelyn, I'm fine with it.
Hold on, I would have to.
You can keep going by fives. Your
Yeah,
boxes
you would just,
will just.
I personally would have just kept going. If I was teaching my students, I would keep going by 5s.
Yep, that's totally fine. So now we're at
Yeah.
20, 40, 60, 80, 100. And then you can add one more little box on the end, right?
Yeah.
Because you need that 8.
Mm-hmm. So you could just do 2.
Yeah. So, and we could write our math problem. We still get the same answer, right? Okay. So now I want you to think about these next problems because sometimes they don't work out exactly. So this is where we get these remainders from, right? Look at these near fact problems. So we know this isn't going to work out perfectly, but can I use multiplication and addition to get there? So for example, when we did our 63 divided by 12, we got 5 remainder 3. And how we did that was 12 times 5 plus 3, right? That's how we would write it to get to 63. So think of how you would do it with these problems. Okay, I'm going to put you back in your breakout rooms so you can try it. Those next problems. I want you to do problems 4, 5, 6, and then we're going to talk about, especially look at 5 is with 0, and that is on your midterm. So I'm going to put you back in your rooms for a couple minutes to think about that. Hello, did you guys get to look at the division with 0, problem 5? I hope. Okay, good. Hello, hello, welcome back. Okay, so I know some of you, I think, were overthinking, getting a little more deep into it. That's totally fine. The groups that I visited were getting a little deep into it. It's totally fine, not a big deal. If you were on my OneNote slide, you saw that I was in other rooms visiting and I was adding things to it, because if you're on it, you can see it change live. I don't know if you noticed that. Tyler's like, yeah, it's annoying. I hate it. I'm just kidding. Tyler's like, no, she's doing our work for us. Here we go.
Oh, yeah, exactly. It's a lot easier if I'm stuck and I look and I go, oh, she's working on this right now.
Nice, perfect. Maybe I'll stop doing that. I'm just kidding. No, I think it's helpful. So a lot of you were kind of combining two ideas. The idea that we were talking about before, which is by this yellow star, where we were like, okay, how can we break down a fact, right? Using our array or our area model. And then we could think about that fractional piece that's left over. That would probably be a little beyond your elementary school students when there's that fractional remainder. But you as college students can understand that, and you can deepen that connection as you went. This was a new strategy called solving near facts. So maybe I can't get exactly there, but can I get close to it? And some of you, this might help you see a little glimpse into our long division algorithm, right? Because that's what we have to do with our long division algorithm. We have to get close to what it is. So you could simply just write it with multiplication and addition. So 7 times something is not going to give me 34, but 7 times 4 gives me 28, and then I'm only 6 away. So that's like your remainder right there, right? So 7 times 6 is 28 plus 6 more. And here it is in long division, which kids don't know when they're first starting this. There's a reason we don't show them long division. So some of you might have been overthinking it. So 9 times 8 plus 3, 8 times 7 plus 4, 6 times 6 plus 2. This one was a little weird because it's really just 4 times 11, and a lot of kids would know that one, right? So, but you could do 4 times 10. The trick is you can't go plus 4, because then you know one more group of 4 fits there, right? So you would have to do 4 times 11 eventually. Okay, and then one group was saying they could write plus 0 to show that there's no remainder there, which is a nice addition. Okay, so let's get to this division with 0. What is happening? Why are there letters L, M, and N? This is connecting you to multiplication and division. Remember, we used that missing factor model. So when we did I can't even remember, one of our first problems that we did, 56 divided by 8 equals, and we would say that was 8 times what gives me 56. So that question mark is the same as a variable. So sometimes in young elementary school, we use a box or something like that. So if you connected this to a multiplication sentence, what would the multiplication sentence be for this problem right here? 0 divided by 5 equals L would be connected to what missing factor problem?
I can say it.
Yeah.
So wouldn't it be L times 5 equals 0?
Yeah. And you could say 5 times L if you wanted to, right? So if we look right here, our divisor became our first factor and our quotient became our second factor. But either way, these will give us the same thing. Can you tell what L would be now? 5 times L equals 0. What times 5 gives us 0?
It would be 0.
Yeah, so this answer must be 0. Now look at this one. What's the sentence, the multiplication sentence for this one?
0 times m equals 20.
Yeah, 0 times m equals 20. What's the answer to that one?
Yeah, you can't really have that.
Yeah. So remember when you learned this as long as division and you just memorized things and you're like, ooh, one of them's 0 and one of them's undefined, but I don't know which one is which, right? If you connect it to multiplication, you should never have that confusion. So because there is no number that I could multiply 0 by and get 20. So this is undefined. Now, this one's even trickier here. 0 times n equals 0. Now, here's the problem. There's not just one unique factor that could go here. There's any unique factor that could go there, right? Sorry, there's any factor that could go there. So that's the problem. That's why we have trouble with this undefined conversation. Did anyone watch the video in the presentation this week on division with 0? It's a good one. Watch it. So there's just our summary. Here's more division with 0. This is very helpful to you for your midterm. So go through the rest of the slides. And we're not going to have a chance to go through the rest of that, but we're picking up partial products tomorrow. So you'll be okay with partial products. Let's just do our exit ticket. Don't forget your midterm starts like what, Wednesday? So I hope you're studying. Come and visit me if you need anything. Try that exit ticket. I'm pretty sure you should be able to do it. I'm trying to remember what it is. I'm going to put it in the chat too. I know not all of you use the QR code. And then you can go. I know it's time to go, past time to go. Sorry about that. All right. Have a good night. If you need me, I'll hang out here for a couple minutes. Jessica, I'm not sure I understand your question. You have a video to watch on the division strategies.
Okay, because when we go on to the interactive notebook link for the Google Doc, it says for week 3 for notes, we have to have division strategies. So
it just needs to get moved to week 4. I just didn't get as far. I just didn't get as far as I thought.
Okay.
Yeah, but you're fine. It can go in week 4 or 3. It doesn't matter. Your team assignment should just be one submission on Canvas, not from today. Like you're talking about your assignment that's due tonight, right? Your big team assignment. Is that the one you're talking about, Karina? Yeah. So you just turn it in as a PDF. One person turns it in. And then it'll go to all of your Canvas assignments.
I have a question about that quiz that's today. It's like a mini lockdown quiz. It makes me nervous. Is it just getting me ready for the midterm like it says and I'm just overthinking it?
Yes, absolutely. Okay. Who took it? Who took it already and can verify? Sunita, should she be worried? Brianna, Vanessa, should she be worried? No, all it is making sure the lockdown browser works.
Okay, cool.
That's all it is. Don't be nervous. I'm trying to do that so we avoid the tech issues when you are stressed and you're taking your midterm, right? Okay. So you already have all the tech issues worked out.
Yeah, if you've never used Lockdown Browser before, it'll just make you download the whole software and everything. Okay. And then just show your ID, do a little sound check, move your computer around, and that's it.
Okay, cool.
Yeah, it's very minor.
On the day of the test, it's going to take like an extra 10 minutes just to download it.
Yeah, or 20 or 30 or something annoying. Yeah. Okay. So, and that's why if I can troubleshoot all the tech bugs now, it helps.
Okay.
So good. Anything else?
I had a quick question, but I can wait like a minute if anybody has something important.
I guess you're it, Madison. Okay. You're important.
Well, our group, we kind of finished. I mean, so for our group project, you wanted us to make like a presentation of our answers together, right?
Yes.
Are we presenting that in class though? Like next week? No?
Nope.
So it's just for you?
Yep.
Okay. I was like, do we have to like, come together again and make a presentation? I mean, like a oral presentation? Okay. All right, then I'm good.
Yay. Did you guys do
Thank
the Google
you.
Slides? Was it your group that did Google Slides? Yeah.
Yeah.
Nope, they look great. You're good.
Yay, perfect. Okay, that was my only question. Thank you.
Yep, no worries. Bye. See you tomorrow. Anyone else? You guys okay?
I had a quick question about the homework. So
I'm ready.
on 2B on the multiplication, I just want to make sure that makes sense. Like 6 times 2 because there's only 2 jumps.
Okay, so is it 6 times 2 or is it 2 times 6? Let's go back to our number of groups and our size of our group.
I would say 6 times 2 because you're going 6, then 12, and it's only 2 jumps.
I want you to think, what does the first number in the multiplication sentence represent? The number of copies or the size of the copy?
0 would be the number, the size.
Like when I taught you the model, I said we want to be consistent in our model. The first number will always be, Vanessa, do you remember? Or Kelsey, do you remember? The first number is always the number of copies, and the second number is the size of the copies. If you go back to our multiplication slides, so it's going to be 6. It's going to be, you wrote 6 times 2,
yeah,
which would say I'm repeating 2 6 times. So if you would write 2 times 6, you're saying 2 copies of 6. If you're saying 6 times 2, it's 6 copies of 2. So think about repeated addition, because that's what multiplication is, right? So are you doing 2 plus 2 plus 2 plus 2 plus 2 plus 2? Or are you doing 6 plus 6?
6 plus 6.
Yeah, in that problem, you're doing 6 plus 6. So it would be 2 times 6. Tricky?
Yeah. So the next one would be 2 times 6 as well.
Yeah, what does the next picture look like? Let me look at that one. Yep, 2 times 6. And then the next one, if you look at the number line one, that's the one that's 6 times 2, right?
Those are those 6 times. Okay.
Because there are 6 copies of 2.
And then we have to write what group they are in, right?
Yeah, so that's fine. So, yep. So you're doing 6 groups of 2, right?
Okay.
Yeah. Good job.
Okay.
I'm glad
that one was tricky because I was like, I think it's 6 times 2 because I'm only jumping twice and not 6 times. But then I forgot that you have to, and I don't know why I thought differently in C. And I was like, oh, I got 2 circles.
Yeah, I don't know. And well, it's probably because the way we were taught, the model wasn't very consistent, you know, but now we were trying to teach a really consistent model. Bye, Kelsey.
Okay. Okay. I got that now.
Better?
Yeah.
Okay. Yeah. Any other questions?
No, I don't think so.
Oh, good. Well, then you're all set. I'll see you tomorrow. Good job.
Bye.
Bye.